Hi, everybody. It's Professor Mitchell. We're starting a new chapter today, Chapter 5, beginning with Section 5.1 on sets. In this section, we'll look at sets and elements, union and intersection, subset and empty set, and finally, universal set and complement. A set is any collection of objects. The objects, which may be countries, cities, years, numbers, letters, or anything else, are called the elements of the set. A set is often specified by a listing of its elements inside a pair of braces. A set may also be specified by giving a description of its elements. Here are a few examples. The set of the first 6 letters of the alphabet is A, B, C, D, E, F. Notice the curly braces around those letters. The set 2, 4, 6, 8, 10 is the set of even numbers between 1 and 11, would be one way to describe it. And the graph of all ordered pairs A comma B, where B is equal to A squared, is a set with infinitely many elements. And for those of you who remember your algebra, this graph is the graph of a parabola. So all of the points on that parabola belong to this set. Here's another example. Let A be the set of years from 1998 to 2011 in which unemployment is at least 5%, and let B be the set of all years from 1998 to 2011 in which inflation is at least 3%. So I'm going to turn my pen on here. Let's see. Okay. I think I might have it working now, maybe. Okay, so what I was going to do was circle the elements that belong to A. All right, that'll work. Okay, so I'm circling all the numbers that are at least 5 under unemployment. And then I'm going to, here we go. Let's take a little shortcut here. And then under inflation, I'm going to circle all the numbers that are at least 3. All right, so we got 2 here, 1 here, and 1 here. Now, I want to be very clear. These numbers are not going to be the elements of A and B, but rather the years in which those occur. So let me do this. I'm going to use red to mark off the years that belong to set A. 2002, 2003, 2004, 2005, and then 2008 through 2011. And then I'll use blue to mark off the years that belong to set B. So 2000, 2005, 2006, 2008, and 2011. All right. Okay, so now, let's see, if we go to the next slide, they're just confirming the answer that we got. So there are the elements of set A, the years 2002, 3, 4, 5, 8, 9, 10, and 11. And B is the years 2000 and 2005, 6, 8, and 11. All right, so now let's talk about the union of 2 sets, and we'll do something with that example. The union of A and B, which is denoted like this, the symbol that kind of looks like a letter U, is the set consisting of all those elements that belong to either A or B or both. And the intersection of A and B denoted A intersect B with a symbol that looks like an upside down U, is the set consisting of those elements that belong to both A and B. So one way that people will remember this is think of union as meaning or and intersection as meaning and. So anything that belongs to A or B is in the union. Anything that is in both A and B is in the intersection. All right, so from this previous example, let's find A union B and A intersect B. So for A union B, just take all the years that belong to either one of these sets. So one way to do that is you can just list all the elements of set A and then pick up the elements from set B that are not already there. All right, so one important thing to note, even though A union B consists of everything that is in A or B or both, the elements that are in both, you only list those once. Okay. Now I have a feeling when I click this, yes, I had a feeling they would put those years in order. That is not necessary. The order in which the elements of sets are listed does not matter, but they did put them in numerical order. Okay, and then for A intersect B, this is a little easier to picture. Just look for all of the elements that the two sets have, whoops, okay, in common. All right, so what I was going to do was underline, there we go, anything that's in both sets. So there they are. Three elements belong to both sets, so those are the elements that get into the intersection. All right. Next, we'll talk about subsets. A set B is called a subset of A, provided that every element of B is also an element of A. So think of a subset. Usually it's a smaller set, kind of a piece of the bigger set is a subset. But note that every set is also a subset of itself. All right, and then the set that contains no elements at all, this is an important set to talk about sometimes, is the empty set or null set, and is written with this symbol here, kind of a circle with a slash through it. The empty set is automatically a subset of every set. That's kind of a logical technicality. All right, so in this example, we will list all possible subsets of the set A, B, C. Now, it's easy to get lost because there are quite a few of them, so I'm going to be kind of systematic about this. I am going to start with a set with 0 elements, which is just the empty set. And then I'm going to list all the sets that have 1 element, which would just be these 3. Then I'll list all the sets that have 2 elements, which would be these 3. And then finally the whole set. So notice that the set ABC has a total of 8 subsets. 1, 2, 3, 4, 5, 6, 7, 8. All right. And finally, a universal set and complement, the set U that contains all the elements of the sets being discussed is called a universal set for that particular problem. So typically what will happen in any given problem, they will specify the universal set. And then if A is a subset of U, the set of elements in U that are not in A is called the complement of A. And we will write the complement of A like this, with it A with like a little apostrophe next to it. Different books write this different ways. So this is how we'll write it. All right. So if U is the letters A, B, C, D, E, F, G, S is the set ABC, and T is the set ACD, let's find the sets S complement, T complement, and then the complement of S intersect T. At any time, like I often say, I encourage you to pause the video, try to figure it out, and then come back and compare notes. All right, so at this point, I will assume that you have done that if you want to. Since S contains the elements A, B, C, S complement would contain all the other letters that are in U, which would be D, E, F, G. Same thing for T. T contains the letters A, C, D. So T complement would be all the other letters, B, E, F, G. Now, the complement of S intersect T, that takes a little bit more work. So first, let's talk about what is in S intersect T. And I believe that's two things, right? The letter A is in both sets, and the letter C is in both sets. So S intersect T without the complement is the letters C and D. Bear with me while I try to write with my mouse. Okay, so the complement would be all the other letters, namely B, D, E, F, and G. I just realized I messed up there, didn't I? I think I said the right thing and wrote the wrong thing. This was supposed to be an A, wasn't it? Okay. Oh dear. Okay. All right. There we go. A and C. So that's why the complement is B, D, E, F, and G. All right. So that's going to do it for this section. To summarize, a set is a collection of objects. Each object is called an element of the set. The empty set is the set containing no objects. The union of two sets is the set consisting of all elements that belong to at least one of the sets, one or the other or both. The intersection of two sets is the set consisting of all elements that belong to both of the sets. Set A is a subset of set B if every element of set A is also an element of set B. In each situation or problem, all sets are considered to be subsets of a universal set. The set of all elements in the universal set that do not belong to the set A is called the complement of A, which is denoted like this. And that's going to do it for section 5.1. We'll see you next time.